Hi everyone, excited to see you all virtually at Pi Ohio 2020. In this Thunder Talk, I will address how to map data with GeoPandas by using data from Pittsburgh's Healthy Ride bike sharing program. I'd like to make note that this data is open source and you can view my analysis on my blog or view my Jupyter Notebook on GitHub for a more in-depth tutorial. I'd like to make a shout out to the open source datasets out there, or else this project would not have been made possible. The data used in this project comes from the Western Pennsylvania Regional Data Center, as well as the Pittsburgh GIS Open Data datasets. A little motivation behind this project I did. I like to do projects with open source data related to socio-technical systems, which mobility and transportation are one, so I chose the bike sharing system in Pittsburgh. I also know that certain neighborhoods in Pittsburgh are low-income neighborhoods, and I have previously done a lot of research on bike sharing programs in cities that are of similar size to Pittsburgh. Take St. Louis, for example, with Lime Bikes. They have a similar population size to Pittsburgh, but they are working very hard to make their bike sharing system accessible to low-income neighborhoods by including pay stations for people without smartphones. Or Manizales, Colombia. Their bike system is free for residents and based on biometrics. For starting off this project, you will need to find some datasets. Here are some general guidelines. You will need at least one dataset that is .shp file type, also known as a shapefile. Shapefiles contain data such as points, lines, and polygons that can represent features such as elevation, city borders, bus stops, locations, etc. Sometimes it is the case where your shapefile also has the categorical or quantitative data that you want to map. Other times, you will need to find another dataset containing the data you want to associate with your spatial data. This is my case, where I found the Healthy Ride dataset, but it was not in the form of a shapefile. It had longitude and latitude values of bike station locations, but it was just a regular CSV file. So in this tutorial, I will walk through how to turn a regular CSV file into a geodata frame and then plot that on a map. For this tutorial, you'll need to import GeoPandas, pandas, as well as some libraries for creating points and polygons. If you don't have any of these libraries installed yet, go over to your terminal and install them. Next, we can load in the data that we are going to use to make the map. I have one CSV file, which consists of the locations of the Healthy Ride station locations, and then I have two shapefiles. As I previously mentioned, these files will contain points, lines, and polygons to make up, say, a city outline of neighborhoods. It is important to make note here that I am turning the shapefiles into GeoDataFrames using GPD. One shapefile is of the census tracts in Pittsburgh, and the other one is of poor housing conditions by census tract in all of Allegheny County. This allows us to perform geospatial operations on vectors, or a geoseries, which makes up a geodata frame. For more information on these geodata frames, visit geopandas.org for their data structure documentation. Once you have your data loaded in, you can now plot your geodata frames by just calling them the name. So we have sendtrack, you can call sendtrack.plot, and it will show you the resulting map or shapefile. In this case, it shows a map of Pittsburgh with outlined census tracts of 2010. As we all may know, cleaning the data is super important. With the Healthy Ride dataset, there was one row that had a negative latitude instead of positive, so it was putting the bike station, say, in South America or Antarctica, somewhere really far away, on the other side of the globe. If you have a dataset with only longitude and latitude fields, and not as a shapefile, you'll want to make sure the data points will map correctly. You can check this by plotting your pandas data frame on a scatter plot. I know generally where all the bike stations are in Pittsburgh, so make sure that all the coordinates of the entity you are mapping match up. After cleaning my data, we can see that the bike stations map out right. If you're familiar with Pittsburgh, there are 3 rivers that converge to a point, and this general shape can be seen here. Now from this pandas data frame, we can take the longitude and latitude and use the Shapely library to create a point to give this data some geometry so it can eventually be turned into a geodata frame. To create the point, we will zip the longitude and latitude points from our pandas data frame into a point. Here's where GeoPandas comes in. We will now create a geodata frame from the original data frame. The defined coordinate system from the northeast area and the geometry that we just defined for making the points. So we have 3 parameters that we're calling in here, and make note that we're calling gpd.geodataframe instead of gpd.readFile like we did on the shapefiles. This is very similar to pandas when you would call pd.dataframe and send in your data. So here we have our original data frame, a coordinate system. If you're not familiar with the coordinate system of your local area, you can search up this on Google to find out and enter in the city that you're located in. And this is the geometry, which it could be a point or lines or polygons. Let's map out the geodata frame head to make sure all of the columns match up right, and then we can move on to the next step. You can now also plot this geodata frame just as we plotted the others. This is known as an overlay. Maps tend to have several overlays. Some can be points, lines, polygons, shadings, multiple different points, etc. But before finishing our map, we have to do some more data cleaning. Next, we need to take our base map, which is the census tracts, and shade each census tract based on the percentage of poor housing. The poor housing conditions map was for all of Allegheny County, and I only wanted Pittsburgh. So I just stripped the census tracts and poor housing data from that map and merged it into the Pittsburgh census tract shapefile I have. As you can see, the top 3 lines here are doing so by taking the poor housing conditions column and the census tracts column and merging them into my other data frame. Finally, we need to create a CHOROPLETH map. A CHOROPLETH map is good for associating polygons with a range of colors depending on a quantitative variable. This step is pretty simple. It is just one extra parameter that we have to add when plotting the map. I'll break up the code a little bit though. So the first parameter, we have the column equal to p poor con, which is what I had set that column to in the last slide when I made a new geodata frame. This will be used in the map to map out the values with a color. The CMap color, you can choose whatever you want, just take a look at the matplotlib for this. You can set the figure size and set an edge color. It is good to have an edge color because some census tracts, in my case, had the same percentage of poor housing conditions and they overflowed into one another. And here we have our CHOROPLETH map based off of our base, which will be our base map. And these colors are based on the poor housing conditions values. Now the final step is to plot the overlays on top of our base map. Make sure that you set the axis to be the same axis as the one you put for your base map. You can change the marker size or the color. I used violet so it could stand out. And we combine them and voila, you have your map. I will warn you the power you have now over making maps. Do not present misleading maps. These maps are meant to provide insight and analysis in a geographical way. If you'd like to see more on this analysis, you can check out my Jupyter notebook here on my website or on my GitHub. Thanks. Here's the full code that made this tutorial possible. My GitHub has a fully fleshed out another analysis on the number of bike racks at each bike station as well. I'd like to make a shout out to carbon.now.sh for hosting such an awesome platform to integrate my code into my slideshow. I'd like to thank you all for watching and thank the PyOhio supervisors for still hosting this awesome conference despite the current circumstances. If you'd like to reach out to me for any questions, head over to my GitHub page and send me an email. Thanks.